what happens is actually we are having this the Palo Alto here, and we have the trunk, layer 2 trunk. Trunk means actually that we can send VLANs actually. All the packets are VLAN tagged. So then here we have the layer 2 switch. This is the switch, and this is our the Palo Alto. And here we have separate VLANs. Here, let's say we have one VLAN here, another VLAN. So then we have VMs, like, let's say we have a PC here within this VLAN. Let's say this VLAN is 10. And let's say this is a server. And let's say this VLAN is 20. So actually our requirement is to, when it comes to VLANs, those are virtually segregated, right? They cannot contact directly. They have to go through a layer 3 device. So in that case, we are using Palo Alto as the layer 3 device. So this is the trunk. Okay, so this is the network we are going to implement. Let me remove this from here. Okay, let me get here. And, okay, here, this from the server side, this is the interface, and switch side, this is the interface. Okay. Then you can hear me properly, right?
Yes, I can hear you.
Okay. Custom shapes, square. Let me get a circle, and let's say the background color. Okay, let's say red. Blue, purple, whatever. Some shapes. Circle. This is my let's say this is the PC VLAN. Let's say this is VLAN. Let's say VLAN 10. VLAN 10. Let's say PC VLAN. PCs. Okay, PC. This is the VLAN 10. And then complicate. And this is the VLAN 20. Okay. Yeah. Text, let's say this is VLAN 20, and this is, let's say, server VLAN. This is server VLAN. Say, okay. Okay, here, and then we have text, the trunk. Because actually, this interface actually we can send. We should be able to send VLAN tag packets, because otherwise, we cannot. Firewall cannot understand this to which VLAN this packet belongs to. Okay, now that is fine. So now we can start the VMs. Let's see the server. Starting by it. Start. Let's start this. Start. Okay, that is fine. This is a starting. Should we remove it? Let me remove it and try. Delete. Yes. Okay. At object not. This should be a Linux. And let's say this is server. This okay. Save. And here. Oh, I just got this. Okay. So I try to delete without. Let me try to add new one. Not Linux. And let's say this is server. Save. Okay. Here. This is fine. Let me try to start this. Okay, it started. Options. Let me do this. Okay, this is VLAN 20, and let me change color. Let's see, this is red. Save. Okay. Okay, now we have two VLANs, and each VLAN we have a PC and server. Okay, so then I think Jay, I told you that when it comes to VLAN, actually we there is no requirement to have the same number. Let's say VLAN 10, 192.168.10 is not mandatory if I'm using 192.168 range, but it's somewhat convenient for us to remember that it's a good practice actually. So in case because of that, I'm using 192.168. Let's say 10.0/24 network. For this VLAN 10. This is the network. And for VLAN 20, I'm using 192.168, 192.168, 20.0/24. Okay, this is the network. So, okay, this is 20. Okay. Okay, these are the networks we have. Now what I can do is let me log into the PC and let me add that IP range. This is the PC. Okay. That's not good. You're there, Jay, right?
Yeah, I'm here.
Okay. Okay. So let me go to wired connection. Yes. Okay, let's change this IP range. That is 192.168.10 dot, let's say 50. I'm sorry. So 168.10.50. And this is fine. And here I'm going to use 254 for the default gateway. So actual default gateway will be the firewall interface. So that is a sub interface actually when it comes to, I'll tell you that when I'm configuring 10.254 and the DNS is fine. Okay, apply. Okay, connect it again. Let me see the IP whether it has been set. IPA. Okay, that is fine. Uh, that is the PC. And let me set the IP for the server. Just 1, 2, 3. Okay. Let me edit the IP here. Settings. Okay, so here I'm going to use 192.168.20.50. That is VLAN 50 IP range. The default gateway is my firewall sub interface. That is 192.168.20.254. Sorry, 254. 254. And DNS is, let's use 8. Apply. Okay, let me reconnect. Let me go to terminal and let me check whether the IP has been set. IPA. Okay, IP is okay, it's fine. So then actually this VLAN 10 PC has 192.168.10.50. VLAN 20 server has 192.168.20.50. And default gateways of these two VLANs would be the firewall sub interfaces because actually what happens is it's my okay anyway let me configure first, so then I'll let it again. Let me log into the firewall that is 192.168.1.100 that is HTTPS is the firewall. Okay, admin. Okay, actually, before configuring the firewall, so what I'm going to do is from the PC, I'm just trying to ping. I'm just trying to ping the server ping because both are in the same switch. 192. Sorry, why? 192. 192. 168.20.50. So actually, we can't ping. Actually, we can't ping even though those are in same switch. But actually, at this moment, these two are in the same VLAN because actually I haven't configured any VLANs, but two different IP ranges. So because of that, they cannot contact. So let me show you the command for the to see the VLANs. You have to go to privilege exec mode. You can use show VLAN. In Cisco Switch show VLAN, you can see actually. Let me remove these two VLANs. I think I created for some other purposes. Okay, anyway, these two are customly created. Don't think about these two. Actually, this is the default VLAN, that is the VLAN 1, and all the ports belong to this VLAN 1. All the ports belong to VLAN 1. Jay, you have idea about VLANs, right? Do you want me to explain it more?
Yeah, I mean, you
Hello.
can explain.
Yeah, sure. I explain. What happens is, uh, let me say that this is, let's say this is the switch.
Please
Okay.
just give me 30 seconds.
Yeah, sure.
Yeah, I'm back.
Okay. Okay, here, what happens is, there's an important term that is called broadcast domain. That is called broadcast, broadcast domain. So what happens is, let's say, let's take a switch. This is a layer 2 switch. We are talking about layer 2 switches only at this moment. So actually, layer 2 switch is actually one broadcast domain. So what happens is, let's say there's a PC. Let's say there's a PC. If this PC is going to send a broadcast, let's say it's going to send a broadcast, then this broadcast is going to be received by all the devices connect to all the switch ports. Let's say we have, let's say for example, we have six switch ports and six devices are connected. So if this device is going to send a broadcast, so all the devices in these ports are going to receive that broadcast. Actually, it's a broadcast, right? So here, one important thing, Jay. So when it comes to a network, let's say we have thousands of host or PCs. So then there are so many broadcasts can be happen because let's say one PC is going to send a broadcast, so it is going to disrupt other PCs. So let's say since we have so many PCs, it's kind of a broadcast storm, whole broadcast storm.
Mhm.
So because of that, when it comes to networking, we have a recommendation. So our best practice, so it is best practice to segment the network, because actually when it comes to micro segmentation, Jay, we have several requirements to do micro segmentation. Micro segmentation means we are breaking the network into smaller parts. So let's say first requirement is actually to reduce the broadcast domain. So let's say we are going to, let's say, 1,000 PCs. We can just break it. Let's say 100. Each network we are having 100 PCs. We can have 10 networks. The first thing. Second thing is actually we can actually isolate these networks. So let's say we have one network here. So actually we can isolate all the traffic within this network in order to communicate with other networks. Actually, we can send them through devices like routers. But when it comes to routers or layer 3 switches, but actually we don't have much visibility, right? So in that case, current days actually we are using most of the cases we are using firewalls. Those are layer 3 devices, but actually they have much sophisticated features to identify threats. Let's say this network is having a kind of a malware. If let's say this is a user, let's say this is a normal user network, and there's a server network. Let's say this is the server network, and these two networks are going to be connected using a firewall, and this firewall has threat prevention features, like it can identify viruses, exploits, and all the things can be identified by the firewall threat prevention features. When it comes to Palo Alto, we have those features. So since these two are two separate networks, actually we have to go through a layer 3 device in order to communicate other network. Let's say this is a server network. So then when this traffic is passing through the firewall, actually the firewall can identify, okay, this PC has a malware and it is trying to do some malicious activity within a server, important servers, let's say online banking server. So firewall can block that malicious request. So that is the second requirement. So first requirement is to reduce the broadcast domain. So in order to reduce the number of broadcasts within a network, because otherwise what happens is, if we are going to have many PCs, and because of this broadcast storms, all the PCs may get slow, because all the time the PCs has to process the packets, because all the time it is getting broadcast requests. So because of that, we have to segregate these networks into smaller networks. That is called micro segmentation. It is a very important concept, micro segmentation. Micro segmentation. So that is very important. So here, the thing is actually we have two options. One option is actually, let's say for example, let's say we have a router, and when it comes to router is a layer 3 device, right? Okay, let's say router or a firewall. And we can have interfaces and we can have separate switches here. Let's say we have one switch here, we have another switch here, we have another switch here. But actually, this is, I think you can remember previously I told you that when it comes to firewalls, we can have separate interfaces and we can have separate networks, right? So, but the same thing, but it is not scalable. So in that case, actually, this VLAN comes to play. So VLAN means virtual LAN, VLAN. So VLAN means actually within a switch, actually virtually we can segregate the switch into multiple networks. Let's say this is a switch. Actually, we have one VLAN here, one VLAN, and there's another VLAN. Actually, these VLANs, even though these devices within these VLANs in the same switch, they cannot communicate directly. They have to go through a layer 3 device anyway. So in this through day setup, actually we are using that restriction to force these devices to go through a firewall in order to enforce layer 4 restrictions. Layer 3 restrictions mean IP level restrictions, and layer 4 means port level restrictions. Layer 7, that means application layer restrictions, and also threat prevention. And we can enforce those restrictions using these VLANs, because the switch is divided into, let's say, 3 VLANs. Let's say we have some devices here, and let's say we have servers, and let's say we have IP phones. And this case, actually, even though those are in same switch, they cannot communicate each other. They have to go through some other layer 3 device. That's most of the cases now with the firewall. So actually, because let's say there's a first thing, because we can enforce security. I mean, we can actually enforce security between these VLANs. And second thing is actually we can reduce the broadcast domains, number of broadcast domains. So because of that, these devices may not get slowed down because of broadcast storms, because this network has been segregated or the micro-segmented, segmented using these VLANs. So I'll show you how to create VLANs here. Uh, Actually, that is the requirement behind VLANs. Let me show you. Okay, here you can see in this switch actually, Jay, we have default VLAN, that is the VLAN one. Actually, this there are another two VLANs like for some other purposes, 10 and 20. So actually, let me remove those VLANs first, and then I can show you how to create.
So default VLAN is different from, is always different from the one that is created, because we created 10 and 20.
Yeah, actually, there's a one difference, Jay. So when it comes to networking, there is something called native VLAN. So native VLAN means I'll tell you that because from the Palo Alto, I can show you that. When it comes to VLANs, actually we have something called native VLAN.
Hmm.
Native native VLAN. Native VLAN. In native VLAN, actually we don't have that VLAN tag. We don't have a VLAN tag. It's actually native VLAN means it doesn't have a. It's a normal IP packet. It doesn't have any VLAN tag. So that is called native VLAN. So when it comes to Palo Alto Firewall, actually, if we want to process native VLAN, then we must have a main interface, not a sub interface, because sub
Mhm.
interface only can identify VLAN tag packet, but
Mhm.
we cannot identify native VLAN packets. So we have to have main interface when it comes to Palo Alto Firewall. Okay, so it's a good question actually. Okay, let me this. Okay, here let me go to privilege access mode, and let me show you show VLAN, and let me go to configuration, global configuration mode, configure terminal, and no VLAN 10. I just want to remove. You can use no VLAN
Why are
10.
you removing it?
Yeah, because actually I created those for some other the previous purposes, so I'm just
Okay.
removing for the moment. Then we'll create it again. No VLAN
Okay.
20, because those are
Yeah,
not
that's
default
true.
VLANs actually. Yeah. I'm using n command in order to go to the privilege exec mode, and let me use show VLANs. Show VLANs. See, now I have only
Only one.
this VLAN, but these VLANs are somewhat because those are special purposes VLAN. Don't think about these kind of token ring networks and those things. Actually,
Okay.
current days we do not use these things.
Mhm.
Actually, at this moment, all the interfaces of the switch belong to this VLAN one.
How many
Everything in
interfaces?
here we
Eight.
have altogether two,
Eight.
four, six, eight interfaces. Eight interfaces. Yeah, actually, when you are adding a switch, actually you can increase the number of interfaces within the.
Okay.
I can show it to you.
Okay.
Okay, so let me go back to the network here. So what? Uh, moment. Okay, here the thing is actually now we have these two the VMs, PC and the server, and both are connected to the same VLAN. But our requirement is we need to have two separate VLANs within the switch, VLAN 10 and VLAN 20, the PC VLAN and the server VLAN. So now I'm going to do that.
Mhm.
Here, let me go to configuration mode, and the command is VLAN. Let's say VLAN 10, and after that you can put a name. Let's say PC. Okay, now we create very simple. And let me go to the privilege exec mode and show you show VLAN. See, now we have another VLAN 10.
Mhm.
The name is PC. And then again, I'm going to the configuration mode, and I'm going to create VLAN. This is VLAN 20,
20.
and the name is server. Okay, now show VLAN. See, now I have two VLANs. But the thing is, actually, even though we created those two VLANs, actually none of the ports belong to these VLANs. All the ports belong to VLAN 1. So now we have to check the physical connectivity and we have to decide which port should go to 10 VLAN 10 and which port should go to VLAN 20. We count here. Okay, E02 is should belong to VLAN 10. E01 should belong to VLAN 20.
Yep.
Okay, let me go to E02. Configure terminal interface. Ethernet. Ethernet 0/2. Okay, the command is actually we have switch port access VLAN 10. We are telling switch port. This is a switch port. Access VLAN 10. This switch port is accessing VLAN 10. VLAN 10. Switch port access VLAN 10. And then we have to tell the mode of the port, because when it comes to a switch, we have two types of ports. We have access ports and also we have trunk ports. Let me tell you the difference between access ports and trunk ports. This is here. This command means actually I'm just asking switch. Okay, your this interface Ethernet 0/2 must belong to VLAN 10. I can show you that.
Yeah.
Do show VLAN. Now see VLAN 10 PC. We have one port here.
Yep.
Ethernet 0/2 belong to VLAN 10 now. So let me do the second port as well. After that, I'll tell you the the difference between the access port and the interface. Ethernet 0/1. Switch port access VLAN 20. Now my Ethernet 0/1 belong to VLAN 20. To show VLAN.
Did you save it now?
No, I didn't save it. You can, in order to save this,
Do
we can use
end.
two options. We can go to privilege exec mode. We can use two options. Either you can use copy running configuration config, startup config. You can use this command.
That's to
But
save it.
yeah, in order to save it, because actually
Okay.
this is in the running configuration. This is because
Okay.
when we are doing something, it is actually it's just after the command it is effective. So because that is in the running config, so we are copying it to the startup config. When the switch boots, so it's going to read this config from the startup config. So this is the one way, and the second way is you can just use write. You can use write enter. Right. So then it is going to be copied to the running configuration, startup configuration. Now it's saved. Okay. So then let me tell you the difference between trunk port and the access port. I think it is. Here what happens is, here let's say we have the switch. For example, let's say we have two switches. Let's say we have two switches. Okay. And let's say these switches, let's say we have two VLANs. Let's say we have this one VLAN and another VLAN. Let's say this is VLAN 10 and this is VLAN 20. And this switch also we have both, say, those VLAN 10 and VLAN 20. So what happens is, let's say we are going to connect a PC here within this VLAN 10, the PC. And let's say here we have a server. So actually, in order to connect a PC into a VLAN 10, actually we have to use the access port. Because actually this access port, this is configured within the switch. This is the access port. Because that means actually this these packets or these IP packets or these packets are not tagged. There's no VLAN tag. This because you have to understand PCs or servers cannot understand VLAN tags. But in certain special cases, some servers has that capability. But generally, we do not use such capability. We use capability of the switch in order to identify the VLAN. What happens is when let's say this PC is going to send some traffic. some data. Let's say this PC is sending some traffic using this port. What happens is once this traffic reach the switch is going to put a VLAN tag. Okay, this packet is tagged with VLAN ID 10. So that is actually access port, because this port, within this port, actually this connection, there is no VLAN tag. The traffic is totally normal IP packet.
Yeah.
But in this case, the trunk port is here.
Between
Between
switch to
switches we
switch.
must have a trunk ports. Here
Yeah.
all the packets are tagged. Let's say this is going through this. Let's say this PC wants to access some let's say PC within this switch, and then when the packet is coming through this link, actually these packets are tagged within the VLAN ID. So then the switch knows where to forward this packet to VLAN 10 or 20. So actually this is trunk port. This is access port. That is the difference between the access port and the trunk port.
Yeah.
Okay. So then let me what happens is, okay, here now what I'm going to do is I'm going to make let's say I'm going to make this port, actually this port access. I want this to be access port, and this is also an access port, and I want this to be a trunk port, because actually we need to send VLAN tag traffic between the firewall, because otherwise firewall cannot identify which to which VLAN this packet belong to. So that's the thing. Okay, let me go to switch, and let me configure terminal, and here interface Ethernet 0/2. I think this is VLAN 10. The command is switch port mode access. Switch port mode access. This port is an access port. And let me exit from here. And let me go to Ethernet 0/1. Let me double verify that. Yeah, 0/2 is VLAN 10. 0/1 is VLAN 20. Okay. The command is switch port mode access. Okay. Now let me show you the running configuration. Show running config and section. Let's say switch port. See, this is our commands. Okay. Otherwise, let me show you not the switch port. Let me show you interface. Okay. Ethernet 0/2. No. 0/. Interface. Let's say interface section. Interface. Okay. Here. Okay. See. This is interface Ethernet 0/1. We have this command switch port mode access. This port is the access port, and switch port access VLAN 20. This port belongs to VLAN 20, and Ethernet 0/2 switch port mode access. This is the access port, and switch port access VLAN 10. This port belongs to VLAN 10. So that is the configuration here within the switch. Okay, so then we have to have another configuration within the switch. I told you that this must be a trunk link. So that means this link should be able to communicate these tag VLAN tag packet. So that's a trunk. So I'll show you how to configure the trunk port. This is Ethernet 00. Okay, Ethernet 00. Let's say go to configure terminal. Interface Ethernet 0/0. Okay. Here, switch port mode trunk, but I think this won't work, I guess. Yeah, there's a problem, because in certain switches, actually we can just use this command switch port mode trunk, but the problem is here it says an interface whose trunk encapsulation is auto cannot be configured to trunk. We have to tell which encapsulation we are using. So that means when it comes to trunking, we have something called .1Q. Because using that protocol, we are putting that VLAN tag. And also there's another thing called ISL, inter-switch link, ISL. We have those two, but current days actually we are using .1 queue. So we have to first tell which protocol we are going to use. Here, let me show you. Switch port, trunk, encapsulation. See, we have ISL and .1 queue. Actually, this is the more this .1 queue is currently using most of the cases we are using this one. So in that case, we have to tell which protocol we are going to use in order to do tagging. I am going to tell, okay, switch port trunk encapsulation is .1 queue. After that command, I can tell switch port mode trunk. Now this command should be accepted. See, now it is a trunk port. We told the switch, okay, please use .1 queue, because actually when it comes to Palo Alto only understand .1 queue, doesn't understand ISL. If we are going to connect two switches, Cisco switches, then we can use ISL or .1 queue. Okay, so then there's another thing I'll tell you. Before that command, I'll show you the trunk link status. Let me go to privilege exec mode. If I'm too fast, just let me know, Jay, so I can make it slower, and you can ask questions. Show interface trunk. See, show interface trunk. I'll send you these commands today. Show interfaces trunk, and we can see the trunk ports within this switch. See, Ethernet 00 is the only trunk port we have here.
Be from the back.
Sorry?
Back. Yeah, sorry.
Okay. So then here the encapsulation is 822.1Q. So that is the tagging, VLAN tagging protocol we are using. And status is trunking. The native VLAN is 1. So that means if VLAN 1 traffic is passing through this, so there is no VLAN tag. And the ports, the important thing is I wanted to show you Ethernet 0/0 VLANs allowed 1 to 4094. Actually, by default, all the VLANs can be traversed through this trunk port. All the VLANs. But the thing is actually, but as a best practice, normally we do not allow all the VLANs. But what we do is, let's say we know, right? We know what are the VLANs we want to traverse through this in the trunk link. So we can actually tell the trunk only allow these VLANs. So I'll tell you how to do that. Configure terminal, interface, Ethernet 0/0, switch port, trunk, allowed VLAN, and we can tell, okay, 10, you can use comma, separate values, 1020. I'm telling, okay, trunk, please allow only these VLANs. So let me show you. Show interface trunk. See, allowed VLANs are only 1020. Other VLANs cannot traverse through this trunk. So that actually that is a best practice, because actually we need to restrict, right? We need to restrict communication. We need to allow only the things that we want to traverse through the trunk. Okay, now we are done with these parts. We are done with we created two VLANs within the switch, and we associate these two access ports to those VLANs, Ethernet 0/2 to the VLAN 10 and Ethernet 0/1 to the VLAN 20. And after that, actually, we configured trunk link here, and we allowed only VLAN 10 and 20. Actually, we need only those two VLANs to be traversed through the trunk link at this moment. Okay, so then let me go to Palo Alto site configuration. So let me go to okay. Okay, I think we open the Palo Alto. Let me hide this, floating control. Okay, we have the Palo. Okay. Let me go to network interfaces and here I think what we connected? This is Ethernet 1/1. Ethernet 1 slash. Now, okay, actually we have some configuration. So let me remove that interface first because it is connected to the trunk. Ethernet 1 slash 1. I just want to remove that interface. Let me delete. I think we have net and all. Actually, I had to remove those because actually we are using those. We go to net rule and U-turn net, I guess. Yes, let me delete. Also, I just disable. Let me because actually that that interface is referenced by this net rule, so that's why we cannot delete the interface. Remove those net rules. If you have any questions regarding this configuration, just let me know. Okay, so okay, it's fine. So interface I know. So okay, actually my requirement or my goal is actually I want to access this server from the PC. This is my requirement. Actually, the traffic, the path should be actually this should go into the switch to the VLAN 10, and through the trunk it can reach the Palo Alto firewall. And now we are going to configure sub interfaces within the Ethernet 1 slash 1. So that means we have two sub interfaces, logical interfaces. This interface is going to be identify the VLAN 10 tag packet. This interface is going to identify the VLAN 20 tag packet. So then when this packet identified by the VLAN 10 tag packet, so actually we can do the inter-VLAN routing within the Palo Alto firewall, and it can reach the VLAN 20 interface. So then through the VLAN 20 interface, actually this packet can reach the server. But actually all these communications can be controlled using the Palo Alto firewall. Actually we can put security policies, threat prevention policies and everything. Using those, we can control this traffic. So done. Let me go to network. Okay, let me select and delete. Okay, okay, now fine. Okay, here the thing is, Jay, actually, the first step is actually we need to tell this interface is a layer 3 interface. Layer 3 interface before creating this sub interfaces. Because actually, I can show you when you select this, actually, you don't. This is a one option add sub interfaces, but it is grayed out, right? We can use it. In order to use it, actually, we have to change it to layer 3 interface. Layer 3, but you don't have to put any virtual routers, security zone. Some people do that, but it is not meant. There's no requirement, because if you are not using this main interface, because unless otherwise you are using, I mean, native VLAN, you have to have configuration here. But for the moment, since you are not using the native VLAN, we don't have to put anything here. Just layer 3. So then you have to click OK. And after that, you can select this interface and you can add sub interfaces. On top of that interface, you can create sub interface. Let's say this is 10, but this number, then we are going to identify the VLAN 10 using this sub interface, but this number is not mandatory. If you want to put 1000 or 1000, I think there's a limited. I can't remember the range, but you can, let's say 5, you can put 5. Let's say you want to put 3, you can put 3. But the problem is it is not that much recommended, because as a best practice, it is good to use the same number here, 10. This is the place you need to put the correct VLAN tag. You must put the VLAN 10 here. This is the tag. No, this is not the tag. This is just a number. But follow this convention, because then you can understand, okay, when you see the interface, so you know, okay, this is VLAN 10 sub interface. Because otherwise, if you are going to put some other number, let's say 3, so it's somewhat difficult way to understand. You have to go to the details and you have to see the tag. The best thing is to use the same number here. And then you have to put these things, virtual router, and this is on, security zone. Let's say, we don't have that one. Let's say, this is, I think, PC views, right? PC VLAN, PC zone. Because actually we can map all the VLANs into Palo Alto security zone. Because when traffic is coming from the PC VLAN, actually it should come into the PC zone, security zone, because right, when it comes to Palo Alto, we have to put security policies between the zones, right? Into zone. So because of that, we are using the same name. If you want to put some other name, users, you can do that, but it's not recommended, because when it comes to network, I think it is better to have same naming convention, because otherwise it's somewhat confusing after some time. Now when you are going to switch, you are using the command show VLAN. You see, okay, there's a VLAN called PC, and then you are coming to the Palo Alto VLAN. See, okay, there's a VLAN called users. There's no VLAN, not VLAN. There's a security zone called users. So it's somewhat confusing, right? But if you're having the same name, okay, the traffic from this VLAN is coming into this security zone PC. Okay, because of that, use that convention. That is important. Okay, let me go here, and you can remember that we are going to use 192.168.10.254. That is our sub interface IP, or the PC VLAN, or the VLAN 10's default gateway is this. And here I'm going to use the ping in order to, then we would be able to identify the connectivity. Okay, virtual route is fine, security zone is fine, IP address is fine, and the management profile is fine. So those, and also tag is here, and the sub interface ID. Okay, let me click OK. See, now it belongs to this interface. It's a sub interface. And then let me create the second one. That is VLAN 20. This is tag. Actually, this is the tag. And here the virtual router. Security zone. This should be server. It should be server. And IP should be 192.168. Sorry, 20.254/24. 20.254, because actually when it comes to these default gateways like routers, firewalls, and all, normally the convention is either we are using the first IP of the range, let's say 192.168.20.1, or the last IP, last usable IP, that is 192.168.20.254, because we can't use 255. That's a broadcast address. Okay, let me go here and let me add the ping. Okay, now fine. IPv4 address is fine, and the management profile fine. VLAN tag is 20, the interface ID is 20. Okay, now we have both the interfaces configured. Now I can just commit and see whether we can reach this. Interfaces using respective VLAN.
There's no policy on the firewall.
Yeah, there's no policy. Yeah. At this moment, there's no policy. At this moment, we are, because actually our way of building this network or the troubleshooting is, first we have to have these interfaces, and we have to try ping the nearest next hop. So that is the, let's say when it comes to VLAN, let's say when it comes to VLAN 10, so we should be able to ping VLAN 10 default gateway, that is 192.168.10.254. And using the VLAN 20, we should be able to ping 192.168.20.254. So that is our initial connectivity test. So after checking that, actually we can go one step. That is, we can go to using VLAN 10. We can try 192.168.20.254. So, but in that case, actually, we need to have a security policy, because actually that traffic is inter-zone, because it crosses the zone. Yeah. Okay, so let me close this. Okay, so let me go here. Let's say PC. Okay, let me try to ping its default gateway. So that is this is PC, right? So ping 192.168.10.254. Say we can ping its default gateway. So that is the firewall. And let's confirm the server. Okay, ping 192.168.20.254. Okay, we can reach the let me try one thing, Ajay, but I'm
Sub
not sure.
interfaces.
Let me. It is actually we are pinging the sub interface. Let me try whether I can capture the packet, but I can't remember whether we can capture. But the thing is, I cannot remember. We need to have a. Give me one moment. Let me. I can't remember. This was somewhere. No, stop the capture. Capture. Just starting. Can do, but I can't remember. We need something. I can't remember what is that. I think.
In the firewall,
Yeah, I know. We need to put the password. Which password? I don't remember that. Okay, let me check. Because from we can actually see the packet caption. We can see all the tags and all. We have to use some password. Which password? Okay, we need to have this file. Okay, let me do that because okay, wrapper, wrapper. That is okay, okay. You change. Okay, okay, okay. Mm, okay, let me go to my Evenchi. Here, this my Evenchi. What? Open. Root. And let me clear the screen. Find dash name. Like a Wireshark. Wrapper.bat. To Dell now. Oh no, that is not there. Create Wireshark wrapper. That thing even. Actually, that is here, not within this. Wow, it is within the file explorer. Check, not here. Um, so, um, you see, is with this and VM, and this is. I think this one, right?
So all of this for the packet capture.
Yeah, actually, yeah, in order to do the packet capture, actually, we have to create a file called Wireshark refer that. So I just to create that because then from that we can actually identify these all the structures. Uh, it's in program as usual. Like the one say okay, give me one moment. We'll do this and I'll tell you. Okay, so then otherwise we are okay. Okay, here now I created sub interfaces within the Palo Alto firewall. These are the two sub interfaces we have. Now what we are going to do is we are going to access the server. We are going to access the server using the PC. Let me try to access. Okay, and clear. Ping 192.168.20.50. Or otherwise, we'll try to access first the server VLAN firewall sub interface.
Where is this?
Yeah, it is within this. Actually, we let me. Actually, I'm within the PC now.
Okay.
I actually ping the sub interface here. That is my VLAN 10 sub interface. Now I'm trying to ping the second sub interface. Actually, that belongs to VLAN 20.
Yeah.
VLAN 20. Yeah. So it is also inter-zone traffic. So then we have to have anyway the security rule.
Yeah.
So let me initiate the ping, and after that, let me see. Actually, I can't ping that. So let me go to firewall and put a security rule. Actually, from the monitor, I should be able to see that. I should be able to see. Which I initiated from here, right? 20. Okay, this is the PC, and from the firewall, let me see whether my security policies, my inter-zone is okay.
We're able to see that log, right?
Yeah, okay. Log session is here, and I should be able to see the traffic. PC2 still okay. See,
No.
PC2 one, this one, right? PC2 server, this one. This traffic is denied. See. Starting from 10 to 1050 to 2254. It's denied. So what I can do is I can put a policy here. I click on and let's say PC to server access, and source is the PC zone, and the range is 192.168.10.0/24. Destination is server range and 192.168.20.0/24. Okay, action is allowed. I'm not going to put any application or services for the moment. Okay, and pick up. Now, after commit, actually, I should be able to see the successful ping. Till that, let me check that file, J, so then we can capture the packets. File is saying, this is okay. Now let me go to PCC. Now we can ping. So then, what I'm going to do is I'm going to ping 192.168.20.50. So that is the server. The previous I pinged the VLAN 20 default gateway. That is the sub interface on the firewall. This is the server. Now actually we have inter-vlan routing now, and it is protected by the firewall. Unless otherwise we allow from the firewall, we cannot communicate between these two VLANs, PC to server. So that is the inter-VLAN routing within the Palo Alto firewall.